So, welcome. Thursday, 5 o'clock Copenhagen time. It's dark, the jumper is on now, and the tea is on my side. And I'm going to look forward to spending the next hour with all you practitioners out there and the staff tonight as well, Dr. Warren Brown. But first of all, I'm Anne-Catherine, co-founder of Nordic Laboratories and DNA Life, a group of companies that's dedicated to change healthcare through functional medicine and personalized medicine. Remember the tests that we are talking about today, the Metabolomix test. You can purchase it for yourself and your patients in your practitioner profile, where you can also find nutritional supplements that you can prescribe for your patients. Remember, the recording will be shared and the slides I've already had, so that they will be shared with you as well. Important, please go to your calendar now already and put a cross for the 3rd of December and the 10th of December. So the 3rd of December, we are going to launch a completely new in the world test. It's going to be called Grow Baby. And on the 3rd, it will be Leslie and Michael Stones together with Emily Ritbom, who's going to go through pregnancy and baby outcomes and how they work. They actually have published some of their work in regards to healthy babies. And they're going to give you a really good introduction for the 10th of December, where Helen Gauci, our genetic expert, is going to take you through step by step the Grow Baby test. So we are really excited, and we will invite you and send invites the next couple of weeks and hopefully see you then. So remember, put a cross in the calendar. So then the last webinar, I touched the base on this health ownership, and the Metabolomix test that we're going to talk about today is helping our patients and helping us as practitioners to understand our patients more. Remember, N=1s, and in functional medicine, there's not really a one size fits all. So that's what we're going to dig in today, into today. And today's star is Dr. Warren Brown, who holds a doctorate degree from School of Naturopathic Medicine at Bastyr University in Seattle. And he's one of Genova's expert medical educators, and he does a lot of education for Genova. And I have listened to some of his talks, and everything is in it. It's very, very structured. So, and it's very, very, in Denmark, we use this word called pedagogisk. It's really building his structure so that it's easy to understand. And of course, at the end, we'll do questions and answers as well. So, and he also runs his private practice in Scottsdale, Arizona, and that's where he's sitting now. And it's morning where you are, and it's dark where some of us are. We might even have some people from Singapore on with us. We normally do, so that's really exciting. Anyway, remember, the purpose of these webinars is also for you to chat on the side, ask questions. I will write them down and ask the questions at the end of Dr. Brown's talk. So anyway, enough from me. Warren Brown, it's you, and you're gonna take on this talk for us.
All right, I'm happy to take over. Can you hear me okay? Is my audio coming through okay?
Yes, you're coming through.
All right, great. And you can see my first slide
yes.
As well. Okay, fantastic. Well, welcome everyone. Thank you for taking the time out of your day to join us. Good evening, good morning, good afternoon, wherever you are. It's a pleasure to be here with you today. Today we are talking about specialty diagnostics for the human metabolome. So let's get right to it. I'll advance to the next slide here. There I am. I've been with Genova for about 6 years, and I'm just really happy to be with you here today to talk about Metabolomix testing. So the Metabolomix Plus is a newer test offering from Genova. If you're familiar with Genova's Nutraval, you'll notice a lot of similarities to that. However, one important difference from this test that differentiates it from Genova's other tests, and particularly the Nutraval, is that the specimen requirements are different. This is a test where the patient can collect their specimen entirely at home. So they do not need to go to have their blood drawn. The test can be performed from a first morning urine and from a finger stick. So really convenient, especially when we have new lockdown orders or things, or patients don't want or cannot get their blood drawn. This is a great test that offers a lot of detail and can be collected entirely at home by the patient. So here are the objectives for today. We'll define the metabolome. We will talk about the Metabolomix Plus profile, as of course, and we'll explain how the Metabolomix Plus arrives at the nutrient recommendations that we'll see provided within the report. And I'll give you a full overview of the report with the optional bloodspot fatty acid part of the test as well. And I will also discuss interpretation and application of test results. And I've included in each slide some notes about each section of the report that you could come back to if you have questions about a particular marker or group of markers. So it'll hopefully be a good resource, kind of a reference resource, and it's all based on information that I've pulled from Genova's support guides. So I've tried to pull everything together for you here in the slides. Let's define the metabolome here. Well, I really like this definition from a publication called Advances in Genetics. You've heard of the genome, the microbiome, maybe the exposome. This is the metabolome. And basically it's a way of looking at metabolites that will provide a direct readout, functional readout of cellular activity and physiological status. So looking across different body systems at metabolic pathways and acknowledging the nutrients that drive those metabolic pathways. So in this way, we have the Metabolomix Plus, and this is sort of the rationale behind it. We're looking for a readout of cellular activity to get information about the patient's metabolism. So the Metabolomix Plus is an extensive collection of biomarkers, and it provides insight into some of the most important biochemical pathways in the human metabolome. These are the ones that we're looking at here: energy production, dysbiosis, neurotransmitter metabolism, fatty acids, which are optional, and I'll show you those in a moment, amino acids, you get some oxidative stress markers, and some optional nutrient and toxic elements. This also gives you a little bit of insight into detoxification pathways. So as I mentioned earlier, this is a first morning void urine collection and an optional blood spot finger stick. So can be collected entirely by the patient in the convenience of their own home. This is what's measured in the metabolomics, and we'll get into these in more detail, of course, but organic acids are a big part of the test. Amino acids, really important for overall health. We can look at the essential and the non-essential amino acids, as well as some metabolites and peptide markers. We have, of course, some oxidative stress markers. Essential fatty acids are optional, and that provides some insight into the omega-3s, the 6s, the 9s, the saturateds. So a great way to help address or assess cardiovascular risk. And then optional nutrient and toxic elements as well. So we'll dive much more deeply into this as we work our way through. I provided this slide just as a reminder that, and this is probably old news to all of you, but I think of reasons why patients have nutrient deficiencies in 3 categories. The first involves delivery. Are they able to take in that nutrient in their diet? Or do they have a diet that's higher in processed foods, or are they just making bad choices? Specialized diets can be deficient in certain nutrients, so we use those therapeutically with our patients to to help address a clinical condition. When we narrow the diet, there are fewer opportunities to get nutrients in. I would say all of those could be reasons related to delivery of the nutrient into the body. Assimilation is another big reason why patients can develop nutrient deficiencies. And that has to do with how well they're digesting and absorbing. So if they're not making enough hydrochloric acid, bile, or enzymes, if they have conditions that impair their ability to absorb, celiac is a good example of that. I would say all of those are assimilation reasons. I would even add SIBO to this list, which is not mentioned here, but when we have overgrowth of bacteria in the small intestine, it becomes harder to absorb nutrients from the diet generally. And then utilization. So are they an athlete, or are they working a job that's physically demanding where they're burning through calories and nutrients more quickly? Autoimmunity can be another reason related to higher needs for nutrients. High stress levels, hormone therapy, medications, toxic exposures, and genomics. So we can start to see a pretty big list of things here that patients come to see us with one or more of these conditions often. So it can be really helpful to look at the metabolome to see these nutrient needs. Here are some common clinical indications for ordering the Metabolomix Plus. There are reasons related to fatigue, stress, and chronic inflammation, mitochondrial dysfunction, and mood disorder seems to be a pretty popular reason for ordering the Metabolomix. But there are also some lifestyle issues, which we've touched on those a little bit in the previous slide, but poor diet, patients who are looking to, who are very physically active, looking to optimize, and of course, nutrient depletion secondary to some of those conditions there. So it's not a complete list of reasons, but maybe some of the more common reasons why clinicians might order the Metabolomix Plus. So here is some conceptual framework that I think is helpful to keep in mind as in a way to sort of help answer the question of why we test the way we do. There are direct indicators of nutrient deficiency that are included in the test. This is just one of the examples: docosahexaenoic acid, DHA. It's one of the omega-3s. It's measured directly, and if we see a low level of it, we can support with that pretty easily with fish or fish oil. So that's something that's measured directly. The amino acids are also measured directly in this test. Functional indicators of nutrient deficiency is where metabolomics really comes into play. And if we're looking at a given biochemical pathway here, A converting into B, converting into C, we know that that pathway is driven by enzymes. Enzyme 1 and enzyme 2 are listed here. Enzyme 2, in this scenario, has a nutrient cofactor requirement that, when it is not met, can lead to an accumulation of metabolite B. And that accumulation ends up in the urine or in the blood. And a good example of that is methylmalonic acid. And if we're using that example of methylmalonic acid, which serves as an indicator of a need for B12, in other words, when B12 is missing here to support enzyme 2, we see this accumulation of methylmalonic acid. Then this would be essentially methylmalonyl-CoA trying to convert into methylmalonyl-CoA trying to convert into succinyl-CoA, which is dependent upon B12. So your methylmalonic acid elevation serves as an indication of that. The nice thing about the metabolomics is you get the best of both worlds. So you're able to see some of the things measured directly, like DHA, and then you also have this functional assessment of nutrient need as well. So why don't we just measure serum B12? Well, Genova actually doesn't measure serum B12 in any of its profiles, even the ones where the patient is getting a blood draw. And the reason why is I've pulled this quote out of the Mayo Clinic's interpretive handbook. They say several studies have suggested that the determination of serum or urinary methylmalonic acid, something that's measured here in the Metabolomix, could be a more reliable indicator of cobalamin deficiency than direct cobalamin determination. So it's one of the reasons why we look at methylmalonic acid rather than serum B12. All right. Now we're ready to dive into the report here. So I'll give you the overview first. The first several pages of the report are the overview and the interpretation at a glance. And so it lists some supplement recommendations, dosages, and some details about each nutrient that we make a recommendation for. That's followed by the pathway and the biomarker pages. And of course, we'll take a closer look at those as well. And then we have the optional fatty acids and optional nutrient and toxic elements available as well. So moving into those first few pages of the report, we see the very first page on the left is the cover page, and provides a big, broad overview of some of the more important nutrient needs. They're organized by normal, borderline, and high need, and in this case we're seeing a high need for alpha lipoic acid, which is not measured directly in the test, but when we see evidence of oxidative damage, that is something that helps to prompt the recommendation for alpha lipoic. We also see recommendations for B vitamins and minerals on that first page. And on the second page, which is shown on the right of this slide, we have a suggested supplement schedule. The DRI column is, in the US, we have daily recommended intakes for these nutrients that are government set standards. We have the patient's daily recommendations, which is what we make recommendations for based on the patient's test result. Those are the color-coded recommendations there, and the amino acid recommendations at the bottom. And then, very important, we have this column on the right side of the second page. It says provider daily recommendations. This allows you an opportunity to adjust the dosage upwards or downwards, or write in a product name, and further customize the test results for your patient. So it's a nice option to have because it allows you some freedom to make some subtle changes to the recommendations that we make here in the test. So ultimately, you know more about the patient than we do, and we always encourage you to make any adjustments that you see fit. The following pages we call the interpretation at a glance, and it talks about antioxidants, B vitamins, and minerals. And I'll zoom in a little bit on these pages. We will use B6 as an example. So if we're zooming in on that B6 page, or the B vitamin page, we can see the recommendation for B6 for this patient is 25 milligrams. The X marks the spot where the nutrient need is. And we also go into more detail about B6, and we talk about its function, causes of deficiency, complications of deficiency, and my favorite of these pages is the food sources, which is this bullet point here at the bottom, which talks about some food sources. So if you want to take a hybrid approach with your patient, where you can prescribe supplements for some things and work on diet for other things, you have some tools here within the report that help you make those recommendations. This is the 6th page of the report, and it's still considered an interpretation at a glance page. We make some calculations on this page. First one is for mitochondrial dysfunction, which is based on abnormal findings in the Krebs cycle markers. So the more abnormal findings we see, the higher the significance will show on this calculation here. Need for methylation, which is also provided here in the upper right. This is based on organic acids and amino acids that are involved in methylation pathways. and provide you a rough estimation of how well the patient may be methylating. And then the toxic exposure calculation, which is based on markers from page 8 in the report, the toxin and detoxification section of the report, which we'll take a look at in a moment. Now we start looking at the actual measured levels of the analytes in the report, starting on page 7. And what we see here is the energy production pathways, the Krebs cycle page, as we call it. And I'm sure a lot of you are familiar with this already. This is how it's organized. We have fats, carbohydrates, and proteins converting into acetyl-CoA, and then participating within the citric acid cycle. We're measuring these intermediates all along the way. This is a good example of metabolomics, looking at the patient's ability to make these conversions. And when we see a buildup of an organic acid, that can signal a metabolic blockage. In this case, if we look at malic acid, it looks to be a little high normal here. And malic acid can build up if we lack the B vitamin cofactor B3. So with an unmet need for B3, we might see malic acid accumulate because of that. The cofactors are mentioned in the green circles here, and the inhibitors are mentioned in the red circles. And we'll see these inhibitors are things like toxic elements, mercury, arsenic, antimony, those kinds of things. So when you see highs or in some cases lows on this page, then you would think, is there a nutrient cofactor that's missing, or is there a toxic element that's inhibiting? This is information that...
Can I just interrupt? Because it's as if something, maybe it's your hand that's touching the keyboard, or there's like a background sound.
Okay, is that better?
Just try and talk, but I think maybe it's when you're touching the keyboard. I can't work it out.
Okay, all right,
Let's
let me
try.
know. Stop me.
I will
Stop me
stop
again
you.
if it happens again. I'll try
Excellent.
to control my enthusiasm here. All right, just let me know. All right, so this is sort of the premise of the test, and gives us some insight into these energy production pathways here. Brings us to this page. We call it the metabolic analysis markers, and these are organic acids. And in the upper left, we have the malabsorption and dysbiosis markers here. We're looking at the first two markers, which are indolacetic and phenylacetic. These are the products of bacterial fermentation of phenylalanine and tryptophan. And high levels here could indicate poor digestion of protein. It could also indicate, in some cases, bacterial overgrowth in the small intestine. The reason why is protein is typically digested and absorbed high up in the digestive tract. And if we're not completely digesting that protein, it makes its way into the large intestine and can come into contact with bacteria, and therefore it can be fermented. These are fermentation products here. Similarly, if we have bacterial overgrowth in the small intestine, then we have bacteria coming into contact at the precise location where we're supposed to be digesting and absorbing. So those two markers help to inform our recommendation for pancreatic enzymes back on page 2 of the report.
So now I'm interrupting again. Someone is asking if you can speak a little bit louder.
Sure. Let's see here. If I hold my microphone,
but others are happy, closer, so it's a balance.
is that better? If I hold my microphone up a little closer?
But yes, I think so. Let's try that.
All right. Let me know. Feel free to stop me again.
Will do.
Right below that, right below those two malabsorption markers, we have the bacterial dysbiosis markers and the yeast dysbiosis markers. And these are metabolites of gut bacteria and yeast. And they do give us a little bit of insight into bacterial metabolism and yeast metabolism. When we see these markers high, it's an indication that there might be some dysbiosis for bacteria or yeast. However, the only caveat I should mention here about that is that when patients have a high intake of antioxidant rich foods like polyphenols in particular, berries, grapes, cherries, things like that, we could see higher bacterial metabolites and maybe even some of the yeast metabolites as well. So in my practice, when I see a result like that, where I have a patient who does a berry smoothie every morning or eats a lot of berries, drinks a lot of green tea, perhaps, if I see elevations in those bacterial and yeast markers and they have no gut symptoms at all, then I am more inclined to think that maybe there are some false positives there. However, most of my patients who aren't eating right and who do not have much polyphenols in the diet, a poor diet, those would be probably more of an indicator of yeast or bacterial dysbiosis, and therefore the probiotic recommendation that we make on page 2 of the report might be more important for those patients. So I think those bacterial and yeast markers are helpful to keep in mind the patient's diet and as part of the interpretation of those. The neurotransmitter metabolites in the upper right, these are organic acids that are downstream metabolites of neurotransmitters and amino acids. And they can give us some insight into neurotransmitter metabolism. There are nutrient cofactors that are really important in these neurotransmitter pathways. Mostly it's the B vitamins, magnesium, manganese, even zinc can play a role in some of these neurotransmitter pathways, copper as well. So those kinds of, those kind of cofactor requirements are taken into account by our algorithm. That helps factor into the nutrient recommendations that we make, but we can get some insight into these metabolites here. One of the more common ones that I see elevated, and we're not seeing it here, but is 5-hydroxy-indolacetic acid. And if you've done organic acid testing before, that one probably looks familiar. It's the tryptophan and serotonin metabolite. And sometimes you can see elevations in that one, which is the third one from the top right here. If a patient's taking an antidepressant, or if they're taking something that impacts the serotonin pathway. So that is something to keep in mind when interpreting that particular marker. If a patient is not doing any particular medication or supplement that impacts that pathway, it serves as an indication of a need for B vitamins, magnesium, and manganese. The markers at the lower left, I forgot to mention, the cellular energy and mitochondrial metabolites we looked at on the previous page. They're just here in list format at the lower left of the page. So they show up again here, but we did look at them on the previous page. That brings us to the vitamin markers here. And these are indications of B vitamin need. So you could think of that heading there where it says vitamin markers as B vitamin markers, essentially. And these are organic acids that accumulate in B vitamin dependent pathways when we have a B vitamin deficiency. And some of these, we talked about one of them already. It's methylmalonic acid, which looks okay in this report at 0.5, but methylmalonic acid, when it's elevated, that helps to inform our recommendation for B12. It's not the only marker we look at to determine B12 need, but it is one of the markers that influences the recommendation pretty heavily. In this case, we're seeing one of the alpha keto acids building up, alpha keto isocaproic, which is an indication of a need for B1, B2, or B3. And we see glutaric acid accumulating, indicating a need for B2. And again, all of this is taken into account with the help of the algorithm that generates the nutrient recommendations. But here we can see the actual metabolites that are, in this section, B vitamin dependent. The toxin and detox markers here start with two common environmental toxins. The first one comes from styrene. It's called alpha ketophenylacetic. And Styrene we can be exposed to through a number of different sources in our environment. Packing materials, food packaging, foam, insulation, paints, carpeting. Unfortunately, the sources are numerous for styrene. And so if we see that marker elevated, we always think about identifying the source, minimizing exposure, and removing exposure as much as possible. But you could also consider antioxidants and nutrients that help support detox pathways. B vitamins are really important in that, magnesium, glycine. So there are things that help support both phases of liver detoxification, can be something to consider if you see these markers elevated. The second marker is alpha hydroxy isobutyric, which comes from exposure to MTBE, which is a gasoline additive. Here in the US, it's been banned, but the problem is it has a long half-life in the environment. So most people here get exposed to that through contaminated water. And so if we see that elevated, we think about water filtration as a way to cut down on exposure. However, this is also something where antioxidants and B vitamins might be worth considering if you see that elevated. Orotic acid is the third one in this section, which tells us about it's a pretty crude marker for a detox response in the liver. So when we see this one elevated, we would think about liver detox even more significantly. And lastly, the pyroglutamic acid is an intermediate in the gamma glutamal cycle, which is one of the ways we can recycle glutathione. And when we see this marker elevated, we would think about alpha lipoic or vitamin C or glutathione support to help provide some additional antioxidant capacity for the patient. Lastly, the tyrosine metabolism marker section. There are two markers here, homogentistic. There's a little bit of literature connecting this to clinical conditions related to connective tissue disorders. So it's, I'd say, limited utility in terms of that particular marker in those conditions, but that information is out there. The 2-hydroxyphenylacetic is a metabolite of tyrosine, but there are some bacteria in the gut that can produce it as well. So in some ways, the 2-hydroxyphenylacetic can be a dysbiosis marker. And when elevated, if you're seeing that one elevated along with the bacterial dysbiosis markers elevated, you might consider some probiotics or maybe looking at a stool test to get more data about gut function. All right. Moving on to the next page. The amino acids are here. The upper left, we see the essential amino acids. We have to get these from diet or through supplementation, and they are measured directly here. So if we see a low level, we assume that either the patient isn't getting enough of that through the diet, or maybe they're having difficulty digesting or absorbing protein. We also have the non-essential amino acids in the lower left of this page. And those can be converted from some of the essentials. They can also come from the diet as well. And here we have these measured as well. Generally, what I like to do when looking at the left side of this page is draw an imaginary line down the middle of the page. And if I'm seeing most of those amino acids on the lower half of the middle, imaginary line there, then I think about asking my patient about their protein intake. Are they getting enough protein? Asking them how well they're, do they have any bloating or GI issues that might prevent digestion or absorption of that protein? And if the patient says, I eat protein, I eat 1 meal a day, it's mostly carbohydrates, well, then I usually talk to that patient about getting more protein in the diet or maybe adding in a protein powder. You could supplement individually with the amino acid recommendations provided on page 2. That wouldn't be a bad idea, but I think ultimately, if you're seeing an overall trend of low amino acids, the most helpful things to think about are poor protein intake or poor protein digestion. And we can see some of the ones that are involved in neurotransmitter production, like phenylalanine and tyrosine. We can see taurine, which has antioxidant properties. It also plays a role in energy production. The branch chain amino acids are listed here: isoleucine, leucine, and valine. And of course, arginine. And many of these essential amino acids have multiple jobs in the body. So it's nice to be able to see which ones are low, and that can tell us something about the diet or the patient's ability to digest or absorb. In the upper right, we have some intermediary metabolites. These are amino acid metabolites that are B vitamin dependent. So when there are B vitamin deficiencies, we sometimes see these markers elevated, and they help to inform the B vitamin recommendations. However, one little clinical pearl I can share is that when the amino acid status of the patient is low to low normal, and I would call this kind of low normal for most of these amino acids here, it can become a little harder to see abnormalities in the metabolites. And so the vitamin markers on the previous page, which are also B vitamin indicators, may be elevated, indicating a B vitamin need. But you might not see that show up here in these B vitamin markers here. And that's because these are downstream from amino acids. So the patient has to have enough amino acids on board for us to see more abnormalities in this particular section of the report. We also have some urea cycle markers, and we look at these for the purpose of determining nutrient cofactor needs. So they help to inform our recommendations for magnesium and zinc, I believe, as well. So they're indicators of needs for those particular nutrients. The glycine serine metabolites, which let me skip back to that slide. Here it is. These are also dependent upon B vitamins, magnesium, and zinc. And so you're starting to see some repetition here. We're looking across different pathways that require B vitamins, magnesium, and zinc. And if we see patterns across different pathways, it helps to make a more reliable recommendation for a particular nutrient, because we're looking across different body systems here, seeing, is there a need for B vitamins in neurotransmitter metabolism, in the organic acids, in energy production, and also here in amino acids and their metabolites. So there's some repetition in this report, but that's a good thing because it helps us to identify themes a little easier. Oh, one other thing I can mention, just a little clinical pearl here about glycine and serine. Glycine is one of the amino acid precursors for glutathione. It also has inhibitory neurotransmitter properties. So if you have patients with anxiety, sometimes a little glycine can help. If you see it low here, you might consider some glycine supplementation. Serine, similarly, can have inhibitory neurotransmitter properties, mostly because of its effect on cortisol. It can help to lower high cortisol levels. So if you see this low, you could consider things like phosphatidylserine. So kind of just a couple little pearls here in this section. If you see low, or if you're concerned about the patient's glutathione levels, that it might not be high enough, I tend to check the glycine level here, the glutamine and glutamic acid here, and the cysteine and cysteine here. So those are the 3 amino acid precursors for, or groups of amino acids that are required to make the glutathione molecule. All right, the peptide-related markers, almost done with this page. These are intermediate steps in the conversion of the crude protein that we take in through the diet and the amino acids that we ultimately need to break it down to. And they sit right here in this graph, kind of right in between that protein from the diet and the free-form amino acids. So if we see elevations in these markers, it helps to inform our recommendations for pancreatic enzymes. So it's another spot in the report that we look to make the pancreatic enzyme recommendation that shows up on page 2. One other little pearl I can share about this section is that when you see the dietary peptide-related markers high or in the upper part of the reference range, and amino acids low or low normal, that builds a stronger case for somebody who's not digesting their protein very well. And that may be the reason why their amino acids are a little bit lower. All right, moving into the next slide here. The oxidative stress markers are next, and these are, there's a lot of published literature on these markers. Lipid peroxides, for example, which tells us about oxidative damage to fatty acids in the cell membranes, and 8-OHDG, which tells us about oxidative damage to DNA. So if you see elevations in these levels, and I would say lipid peroxides in this case is high normal, 8-OHDG is normal, then you could think about antioxidant support to help that patient because they have some evidence of oxidative damage here. That means they don't quite have the balance between the antioxidant capacity that they need and the amount of pro-oxidants that they're faced with. So this is a piece of information. It helps to inform the alpha-lipoic recommendation that we saw on the first page of the report. This little clipping here on the slide at the lower right was taken from our NutriVal support guide, and it talks about some other ideas beyond supplementation like antioxidant-rich foods, omega-3s, etc. So that's comes from our NutriVal support materials, and it's very pertinent for these two markers here. Moving on to the next slide here. I apologize, my computer's being a little sluggish here. Now we get to the optional parts of the test. So everything we've seen so far is included in the Metabolomix Plus. You have the option to add on bloodspot fatty acids, toxic elements, and nutrient elements. And let's get into those right now. Starting with the fatty acids. There are 2 pages of fatty acids. This is the first. In the upper left, we're able to see the omega-3s, the omega-6s, and the omega-9s. To get a sense of balance between those, I look at the percentage at the bottom of each category. So we can compare the percent omega-3 to the percent omega-6 and to the percent omega-9. And pretty quickly we can get a sense of if this patient has a pro-inflammatory pattern or not, because if their omega-6s are very high and their omega-3s are very low, that would be a pro-inflammatory pattern. In this case, it actually looks pretty good for this patient. So this seems to be on account of the alpha-linolenic acid at the top of this page, which comes from flax or walnuts, chia seeds, things like that. EPA, which comes from fish or fish oil typically, and that looks pretty strong as well. And so the overall impression here when it comes to the omega-3s is a pretty good one. At 4.9, it's a pretty good result. There are some sources for these omegas listed underneath each heading. It's showing up kind of small here on the screen, but in the report you'll be able to see that the omega-9s come from olives or olive oil. The omega-6 sources and omega-3 sources are listed here as well. You can also get a sense of the balance between the saturated fats and the monounsaturated fats here. And similarly, to get a sense of the overall saturated fat intake, I look at this percentage here at the bottom of the category. So 39.1, this patient looks like they're limiting the amount of saturated fat that they get. So maybe they're getting more fish from the diet in terms of fat sources, maybe more fish than animal fats or coconut or palm oil or dairy even. But you can see the overall sense of saturated fat intake here. You can also see the monounsaturated fats on the right-hand side of the page. And there are some cardiovascular risk markers here as well. Probably one of the more, I'd say one of the more important markers on the page is the omega-3 index, which is, there's quite a bit of published literature on this, indicating that A level of 8 or higher is cardioprotective. If the patient's result is between 4 and 8, it's intermediate risk for cardiovascular issues. And if it's below 4, it's an increased cardiovascular risk. So it's provided here, it's calculated for you. And in this case, the patient looks to be in a pretty good position. The second page of the fatty acids looks like this. We plot out the omega-3s and 6s in pathway format. And the nice thing about this page is we also provide a reminder of the enzymes that make these conversions for us. Not only that, but the nutrient cofactors that drive the enzymes. So in this case, the delta-60 saturase converts linoleic to gamma-linolenic. That looks like a pretty good conversion there. The elongase enzyme converts from gamma-linolenic to dihomo-gamma-linolenic. That looks like a pretty good conversion as well. One of the reasons why we care about this one so much is because it does provide some anti-inflammatory activity for us. So it's one of the few omega-6s that actually is anti-inflammatory. You can also see the pro-inflammatory omega-6 here, arachidonic acid. So just a nice little adjunctive tool to help remind us of the cofactors and the anti-inflammatory and pro-inflammatory omegas provided here within the report. You have the option to add on some toxic elements, and when you choose just the toxic elements, this is what the result looks like. If you want to add on the toxic and the nutrient elements, the report looks like this. So same toxic elements, whether you order them as an add-on by themselves or as an add-on with some of the nutrient elements. They're all measured in urine. So it is a pretty short snapshot of toxic and nutrient element exposure, so to speak. 20 toxic elements are provided, 15 nutrient elements are provided, and this would be, of course, in urine. If the patient for the toxic elements has a result in the bright red part of the reference range, that's kind of the danger zone, and where we see more frequently, we see clinical symptoms associated with that toxic element. So we want to keep them out of this bright red part of the reference range for sure. If, for instance, if we're seeing lead here, we'd still think about trying to identify the source and avoid exposure. If we see it up here, we'd think, well, this could be a pretty serious lead toxicity. So that's provided for you there. And again, probably somewhere along the order of 48 hours status for the patient. The nutrient elements are on the right side of the page, and we can see them measured directly here. I'd say most of the time I see 2 or 3 of those nutrient elements on the high side, and I'm okay with that because this is a short snapshot, and the diet will be occasionally higher in copper or higher in zinc or higher in selenium on a fairly routine basis, but that may not be true all of the time. I tend to think of high nutrient elements more of a problem if I see them chronically elevated and the patient has high oxidative stress markers, things like that. So it's a very short snapshot, so it's not too uncommon to see 1 or 2, maybe 3 of those nutrient elements elevated, especially if they're taking a multivitamin or something along those lines. This is a comparison slide. I'm not sure how relevant this is for you all, but just as a comparison between our NutrEval, the Metabolomix Plus, and the ion profile, you're getting organic acids in all 3 of those, amino acids in all 3 profiles, oxidative stress markers, and those are all in these 3 profiles. Glutathione's only provided in the NutrEval, CoQ10 in the NutrEval or the ion. The fatty acids are available in all 3 if you add them onto the Metabolomix. Vitamin D is not, because we can only get that from serum. Toxic elements. The edge here is that the Metabolomix profile gives you 20 toxic metals. The NutrVal and the ion only give you 5. However, they're different specimen types. So the toxic elements in the metabolomics, they come from the urine. The toxic elements in the NutrVal and the ion come from whole blood. So whole blood's advantage is that it gives you a little bit more history, probably up to 3 to 4 months, maybe a little less than that. But you do get more toxic elements in the metabolomics. And then a few of these other things. This is probably the main takeaway for today. Does it require phlebotomy? And the answer for the NutrVal and the ion is yes. The patient has to go get their blood drawn. It has to be spun, it has to be processed, and it has to be sent away. The metabolomics, the big advantage is that there's no blood draw required, only a first morning void urine and an optional blood spot. The buccal swab would be for genomics, which are only available in certain areas. So that really is not pertinent for our discussion here, but urine and blood spot is. And of course, the report summaries are part of the NutrVal, they're part of the metabolomics, not to some degree, they're part of the ion, but it does not feature nutrient descriptions along with that. So that is the overview. If you're looking for additional educational resources from Genova, you can check out our website, gdx.net. The MAP support guide, the NutrVal interpretive guide, are the best tools we have for interpreting the metabolomics at the moment, although we will be at some point combining all of our nutritional metabolomic support guides into one. You can also see webinars and educational modules on the website. We have a podcast that you can subscribe to. It's free, but the episodes are available on gdx.net or Apple Podcasts. And then, of course, if in the US, clinicians can call us and ask questions. I'm not sure how that support is if that's relevant to you all, but these are some of the support resources that we have here in the US. That's all for today. I'm happy to answer questions. If there are any. Thank you for your time. Thanks for tuning in and bearing with me for the audio issues. I'm sorry about that, but I really do appreciate your time and taking the time out to join me today.
Thank you, Warren, very much. See, I told you all, very thorough, very structured and so on. And we've learned a lot and are less afraid of digging into a test like that. So a few questions came up. A lot is like accuracy in regards to the metabolomics test, in regards to NutrVal and ion test. What can you comment on this, please?
Sure. There's a lot of overlap between the metabolomics and the NutrVal, and so the organic acids are identical in both tests. The fatty acids are a little bit different because of the specimen type, but it's the same fatty acids that we're measuring. And as far as the accuracy, they line up really well. Now, the thing that you might see different is in the toxic element measurements, because there are fewer in the NutrVal than in the metabolomics, and they are a different specimen type. If you ran both tests on the same day, you might see different information for the toxic metals. The reason why is you get more history in the NutrVal. In the metabolomics, it's a shorter time frame. They're both accurate, but the metabolomics toxic elements is a shorter time frame. The NutrVal is a longer time frame. So
is a NutrVal toxic elements, is that in blood?
In whole blood, correct.
Okay, so that explains its different collection types. One was asking in regards to doing this test, would you suggest doing DMSA prior to, as a provocation to doing this test, so that you can see what's more excreted as opposed to only this short window of exposure to toxic elements?
It's a good question. I typically don't, and the reason why is I want to see what their current toxic exposure is. And typically, when I think about provoking a patient and testing their results to look for stored levels, I will do that based on a first morning void urine. Then I'll have them take a provoking agent, and then I'll check them again 6 or 8 hours later. And that way I can compare their current exposure to their provoked levels. And if I see, for instance, mercury or lead or any other toxic element go from normal to high, then I'm assuming that it's stored. You can use the test however you'd like, but typically what I see clinicians doing is ordering this test as kind of a general survey of their toxic exposure and their metabolome, but not using it with provoking agent. That's probably what I see most of the time.
Super. So, I mean, I'm used to using a lot of organics tests, but I can see here that if I want to know more about more nutrient information, of course, this becomes a more interesting test. So, like, you would choose this test if you want to know like a more rounded information in regards to nutrient markers and amino acids and fatty acids. And of course, you can, in our profile, you can add a blood spot vitamin D as well, because that's kind of missing here. But you can add that to the order as a separate test in the same order in our system, so that you get that as well. So that's quite neat. Another thing was we came up with the stability of this would be the same as the organic acid test, right?
Yes. So it's the organic acids are run in the same specimen type on the same equipment in the same way. So I would imagine the stability would be the same as the NutrVal.
So we need it. So basically, when the patients are collecting, I would say that they collect in the morning and preferably ship in the afternoon, or at least next day. So it has to go quite quick. They can't store the urine in the freezer for a week and then send it. Then it will be off. So, but this will be in the instructions, and also like if they have to avoid taking any specific foods or nutrients, that's in the instructions as well. So just always ask your patients to read the instructions thoroughly, follow it, and then everything will be good. Some questions did come up in regards to the creatine, but I know if creatine is too low, the test will be canceled in the lab, and we will contact you or we will contact the patient and ask for a new collection, and we will drop ship a new collection kit. So you don't need to think so much about that. And again, if they follow the instructions, all should be good, unless they have some weird metabolomic, I don't know, some weird genes or something that we don't know of, and it might look different. So I'm just going to ask, because this is a question, and this was something Richard Lord years ago taught me. So when I had an amino acid test, with all the amino acids showing really high, like weirdly high, like I would go through the dietary interview and I would calculate how much roughly is this patient eating with protein, what's their digestion like, and it just doesn't fit with such a high pattern in the test. I know he was talking about B6 and zinc as cofactors, but do you have any comments to this?
Yes. Sometimes I see that with very low urine creatinine, that the organic acids show up a little more robustly than I expect. And I think that's because they're provided as a ratio to creatinine. So that may be one possible reason. So, and most of the time, low urine creatinine is because the patient is either overhydrated, or they didn't collect their first morning void, or maybe they woke up within 6 hours of, or maybe they woke up at night to urinate and didn't combine that with their first morning void, so we have a more dilute urine. Sometimes you see it in patients with very low muscle mass as well. But when the organic acids, or when the creatinine is low, the organic acids and the amino acids could show up a little higher. The other reason, when I see high amino acids, and to some degree organic acids, I think about B vitamin needs, as you mentioned, and mineral needs, because the Bs are critically important to amino acid metabolism, and organic acids as well. So sometimes we see accumulations because, for instance, in the amino acids, you might see a high taurine or a high threonine or high branch chain amino acids, and the patient is not taking in a lot of those in the diet. Often it's because they lack the B vitamins to help metabolize and utilize those amino acids. So I think you're absolutely right. I think could be B vitamin recommendations, but also check the creatinine. If it's really low, that may have some influence on it.
So it's so someone is asking, are you talking about creatine or creatinine? It's the creatinine, and you can see it on the sample report. You can actually see
Yes.
the concentration.
You can, yes. It'll be at the lower left of the fatty acids, or I'm sorry, lower left of the organic acids page and lower left of the amino acids page.
But just remember, if it's too low, the test will not be run.
Right.
So if it's within, like if it's high enough, the test will be run and you can rely on the results. But then of course there's little patterns that you then might have to ask about or revisit this webinar when you do your first test. One is asking, just as because another question came up also on B12 and so on. So it's this methylation. So this one comes up. If someone is over methylated or over supplementation with methylated B vitamins, would this show up? Would there be a pattern that we can see some form of over?
In terms of over methylation, I think there is some merit to the concept. However, I think it's hard to see in the Metabolomix and even in the NutrEval. In the US, we do have a test called the methylation panel, which does provide some insight into that. If we see higher SA levels and lower, higher SAM levels and lower SA levels, that's typically, in my mind, maybe one of the best ways to determine that. But it can be, the things I would look for in the Metabolomix profile would be normal needs for B12 and folate, but that wouldn't necessarily mean over methylation. It could mean that they're meeting their needs for B12 and folate. However, if they're taking a high dose of B12 and folate and you're seeing normal needs and they're having symptoms that are consistent with overmethylation, like anxiety, irritability, general sense of just not feeling very well when they're taking them, then I would consider overmethylation as a possibility. But I wouldn't say there are solid markers in the test that could help identify that with specificity.
Yeah, but exactly with the methylation panel, you can look more into it, but that's actually perhaps more looking at under methylation. But then you also might want to look at genetic tests to see if what the different genes related to methylation are telling you, if there's a predisposition. Of course, they won't say over methylation either, but at least you get a broader insight into some of the methylation markers that and can perhaps understand the patient better. And of course, yeah, over methylation, and we get these psychiatric issues, then you might want to reconsider the treatment for sure. But yeah, the offers are there. So I think we've learned a lot so far. Hopefully we can invite Dr. Brown back again another day and talk about something else. We'll see.
I'd be glad to help.
Yeah, so but thank you very much so far. And now we were up to 130 people, so that was really good. Some are running off now to do what they have to do. But I just want to remind all of those who's still hanging in there that we will be back on the 3rd of December and again on the 10th of December with our new test together with Leslie and Michael Stones and Emily Ritbom in regards to Grow Baby and genetic testing. So we are very excited to launch that test, and we'll do it in a 2-part because we think there's so much information to pack in there in regards to that test. But of course, Metabolomix, in order for optimal pregnancy outcome, is for sure important, because we want our mothers and fathers, for that matter, to be as healthy as possible at the point of or time of conceiving. So hopefully we'll see you then. And the recording, it's still recording. Zoom is amazing. And we will share the recording with you. And Dr. Brown, the good boy in the class, has shared the slides with me already. So they will be be in the mailing that we will send out. And also there will be a good offer for you on the Metabolomics test if you want to do it on yourself or a close friend or family member or one of your patients. So thank you, everybody. Thank you, Dr. Brown. We'll be in touch. And
yes, sounds good.
Yeah.
Thanks, everyone.
Thank you. Bye.
Have a great day.
Likewise. Take care.